Hello Year 10. First job this week is a little bit of recall. We've got 3 little tasks that you're going to jot down on a piece of paper. Draw 7 circuit symbols with their names, write down the equation for gravitational potential energy, and sketch a quick graph showing how the resistance changes in a LDR as you increase the amount of light. Okay, so you want to pause the video here and do those 3 things nice and quick. Take about maybe 5 minutes, less than that. Okay, so 7 symbols, write the equation of gravitational potential energy, and draw that sketch graph. So pause the video here. Excellent. Hope you've now done those 3 things. Here are some answers. So we've got all of the different symbols that you need to know. So we've got a switch, open and closed. We've got cells, batteries, diode, resistor, variable resistor, LED, light emitting diode, a lamp, fuse, voltmeter, ammeter, thermistor, and LDR, light dependent resistor. So you can have the equation for gravity in either the word form or the symbol, so mass times gravitational field strength, how strong gravity is, times by the height, or mgh. And then we've got the resistance and light intensity graph, where it's dropping. The light intensity reduces the resistance reduces. It gets lower as we increase the light intensity, so resistance is going down. Okay, right, now, over the last week, you've uploaded some brilliant work looking at those equation practice. Okay, just a couple of examples. We've got beautiful work here. The that first starter where we're labeling and annotating the EM spectrum was really good quality. We've got some really strong workings out. Okay, but I just want to draw your attention to one question where there were quite a few mistakes. Okay, so this is a absolutely fantastic piece of work. We've got some really clear workings out here. We're using units. We're writing down our workings. All the answers here are correct. Okay, really beautiful work. Crossing out things that are wrong. You know, really solid piece of work here. But this question here, lots of you wrote something similar to this. The energy is used up in the component. Where is the energy going? It's used up in the component. It goes away. Okay, that's not correct. When an examiner reads that, they're going to think you don't know about that really important rule for energy. Okay, I want you to say out loud after 3, what is the most important thing you've ever learnt in science, in physics in particular? In 1, 2, 3, the conservation of energy. If the examiner reads the energy is used up, they're going to think you don't know that. Okay, because the energy can't be used up. It's just changed what type it is. It's shifted about. It's transferred from one store to another store. Okay, so you can write things like it's lost to the surroundings. Okay, it's transferred as heat. Transferred to a different energy store. It's not that it's used up. Okay, so it's a wonderful piece of work, but if you answer a question like this, you've got to be really careful with it. Okay, never say it's used up by something. Always say it's transferred to something else. Try to figure out what that is. Now, most of the time, it is transferred to heat. Okay, most of the time, some energy is transferred to heat, especially when we're talking about efficiency and lost energy. Okay, right. Next. Just some answers. These will be uploaded along with the class charts for the last set of questions. If you want to have a look through the video here, you can pause the video and you can have a look. But they'll be uploaded with the class charts. This week, we're staying with our electricity topic, but we're moving on to something new. Okay. Now, your first activity, you are going to need to get 2 songs. Not 1 this time, but 2. They shouldn't be too long. Okay, 5 minutes maximum. 4 minutes would be fine. 3 minutes is probably even better, but I know there's not actually that many 3-minute songs that are good. Okay, so 2 songs that are 4 minutes or so long. You need a piece of paper or something that you can draw on, and you need something to draw it with, so a pen or pencil or whatever. Don't mind which. Okay, if you've got colours might be helpful, but they're not needed. Okay, so pause the video. Honestly, I've got everything like that ready. Okay, so hopefully you have those 2 songs, something to write with, something to write on. Here's what's going to happen. Next screen, okay, is going to be a diagram. Okay, I'm going to show you that diagram, and you're going to look at it, and you're going to try and memorise it in the length of your first song. So you're going to be watching that that picture. You're trying to memorise all the detail. Okay, and you've only got that first song to do it in. Okay, then when that song finishes, okay, you need to minimize my video, turn it away because you're trying to remember, and then in the length of your next song, you need to draw that diagram. And then finally, you need to sit back, look at how amazing your diagram is, and be very pleased. Okay, so hopefully you've got those two songs ready, and you've got that pen and paper ready. So the first job is to look at the picture, try and remember as much as possible. Look at the detail, look at the text, look at the spelling. Okay, then you're going to be using a second song to play it. Okay, so here is the picture. Get ready to play your song. Start your song now. Here's the picture. Pause the video. Look at it. Hopefully it's now finished. Now is the time to minimize and stop this video and draw out that diagram. And now, hopefully, you've played your two songs. It's like 10 minutes later, and you've got a picture of this. Okay, what do you think it is? This is the national grid. Okay, this is how we get electricity from our power station to our home. Okay, it goes through a series of these things called transformers. It goes through power lines, cables. Okay, and it has different voltages. What is the voltage that goes into our house? I wonder if you've written it down. I'm going to tell you in this video, but I'm not going to tell you yet. I just want you to try and have a think about what it might be. Now, there are lots of different ways that you can show this as a diagram. This is one way. We've got other ways. These are a little bit more confusing, a little bit more complicated, but we've got a power station. We've got some transformers here. These have got some of the different parts. We've got heavy industry, light industry. They're going to have slightly different voltages and requirements for their electricity. Okay, some industry is going to need a greater voltage than you will in a house. Okay, here it goes into how they generate the actual electricity. So we've got the coal, we've got the furnace, we've got the turbine, we've got the generator, then we've got the transformer. It's going through our pylons, then into another transformer into our houses. The bottom of my picture there's cut off. That's another way of showing it. Here's the BBC bite size diagram. So we've got power station, step up transformer, high transmission line, step down transformer, and then consumers, houses, shops, factories, consumers in terms of who uses the electricity. Okay, now you need to know this diagram. You need to know how to label it, and you need to know the different parts of the national grid. Okay, now the transformers, okay, are a crucial part of this. Crucial. But you won't get to learn how they function, how they really work, until we look at the magnetics topic. Okay, so it will come up again next year when we're back in school, hopefully. Okay, but what they do is they are able to control how much voltage and current there is in a circuit. Okay, so the voltage going into a step-up transformer, okay, on the other side, it will be stepped up, it will increase, it will get bigger. On a step-down transformer, the voltage gets smaller. Okay, so we've got a high voltage in the middle here, and lower voltage going into our home, and lower voltage even coming out of the power station. Okay, so as well as stepping up the voltage, okay, they do something else. Now, thinking about that really important rule for energy, we can't create energy or destroy energy. We can only transfer it. By increasing the voltage, it might look like we're making more energy. Suddenly it's increasing the amount of energy. That's not what's happening. The total energy going into a transformer is almost identical, they're really efficient, to the total energy coming out. So the total energy in the high transmission is going to be really similar to the energy coming out of the power station. You lose a little bit through heat, okay, in that transformer, but for the most part we can actually assume that it's identical, okay, because step-up transformers are very close to being perfectly efficient, okay, especially the big ones that the national grid uses. Now, so something else must be happening, because if I'm increasing the voltage, something else has to change, and that's the current. The current will decrease, okay, and it's important that we know, have an understanding of why that might be helpful. Okay, and I've got this analogy with trucks. Okay, what's more efficient? What's safer for the road? To have 1,000 lorries, each carrying one bag of coal, or one lorry having 1,000 bags of coal. And it's obviously this one lorry carrying that 1,000 bags of coal. The coal represents our energy in our circuit. The lorries represent the electrons. So here in this top picture, we've got a massive current, but a low voltage. Here we've got a massive voltage, but a low current. Okay, the total energy in the pictures is the same. Okay, and that's why we use high voltage transmission lines in our national grid. They are much more efficient. Less energy is wasted as heat. Okay, and that's why we use it. Okay, and then like I say, transformers, they're going to come up again in the magnetism topic when we're back in school. Okay, but what you need to know at the moment is step up transformer, the voltage goes up and the current goes down. Sorry, this voltage goes up, current goes down, and step down, the voltage goes down and the current goes up. Okay, but the energy on either side of the transformer is the same. So, your first task, your first proper task, you need to look at that diagram that you've already drawn and you need to update it with some more information. Okay, now if your sketch is not beautiful, you can choose if you want to restart and redraw. That's up to you. If you think it's pretty good, or think it's alright, or think it'll do, you can just annotate and add to it. So you want to add some different voltages to the diagram. Okay, you can use BBC Bitesize to help you figure out what those voltages might be. You want to maybe have a little sentence talking about why we transmit it at high voltage, thinking about energy efficiency, thinking about less energy lost as heat. Okay, low current, low power loss to heating. You want to label or have a little sentence describing why it's better to have a low voltage, 230 volts going into our homes. Why would we have 230 volts going into our homes? Why don't we just keep it at really high voltage? And then some of you might be able to talk about why we want to keep this up high. Why do we bother going to the effort of putting it on big pylons? They're expensive to build and harder to maintain. Why do we put them on big pylons? Why do we have these wires up high? Okay, those are your 4 little jobs. Spend maybe 10-15 minutes, okay, on this. If you get really stuck, you can move on after maybe 5, 6, 7 minutes, okay. But 10 minutes or so, I'd expect to finish annotating your diagram. Okay, and upload that as part of your work to class charts. Super. Right, the next job, okay, you want to jot down these questions. I know it's rubbish writing down questions, but you're going to need to write them down because you're going to be watching this video that's going to be in the description of my YouTube video, and it's going to be linked to you on class charts. And you need to be able to answer these questions while watching this video. Okay, this is the last thing we're probably doing. Okay, so you need to jot these questions down. They're going to be attached in class charts. If you've got 2 devices, you maybe don't need to jot them down. So if you've got a laptop and a phone, you might be able to keep the questions on the laptop and watch the video on your phone and then write them down. But I think it's just easier to write the questions down. So jot the questions down, watch the video and answer the questions as you go. Okay, hopefully you found that interesting and you liked the EastEnders theme tune. I like the EastEnders theme tune. I think it's a great little piece of song. And you've answered these questions. So I've also attached this little worksheet as an extra booster. Okay, you can choose to do this as voluntary if you want to, if you think it'd be helpful for your understanding of the national grid, or you find this easier than some of the other activities. You can also do this as a worksheet as well, but this is completely voluntary. I hope you're having a good time at home. I hope you're staying safe. I hope you're looking after your friends and your family. Take care, everybody.